When it comes to studying the brain and its relationship to behaviors and mental processes, we need to find a way to measure the brain, ideally doing so in a relatively non-invasive fashion. We're going to walk through several different types of brain scans. I encourage you to write this chart down in your notes. We will be discussing the EEG, the CT scan, PET scan, MRI, and the fMRI. For each of these, I'll provide a brief description of how the test or how the measure is used, and then we will identify whether this measure is appropriate for looking at brain structure or brain function or level of activity. Once you have this chart down in your notes, I suggest you move forward with the rest of the video. Now that you have your chart ready to go, let's begin with the EEG. The EEG will use electrodes that measure electrical impulses throughout the brain. So as the brain communicates and sends out action potentials, the electrical charge within the brain changes. Depending upon the amount of activity, we'll see different peaks within this EEG report, which looks something like this. An EEG can be fantastic if what we want to look at is brain function. But as you can see from this EEG here, it doesn't tell us anything about structure. So if you're interested in location of energy or activity, the EEG is probably not ideal. The EEG has another advantage in that it is incredibly easy to use if you have someone who's going to be moving a lot. Many of the other scans require someone to lay very still to get a good reading or get an accurate or valid reading. With the EEG, we can still get a good reading even if someone had these electrodes on their head and they were running on a treadmill. The CAT scan, you can see, produces a slightly different image than what we got out of the EEG. The CAT scan is going to employ a detailed X-ray that images soft tissue, which allows us to see various structures in the brain. However, as you could probably discern from these pictures, it doesn't tell us much about what's going on in those structures. So the CAT scan or CT scan will be useful to tell us anything about structure or potentially location, but does not tell us much about function and activity. CT scans are commonly used if we are looking at where the brain is damaged or perhaps looking for where a tumor might be present. The PET scan uses radioactive tracers to measure glucose use. By measuring how much glucose is being used, we are able to determine level of activity in the brain. So the PET scan is a great measure if we are looking at function. However, the PET scan is not overly useful if we really need to understand structure or location. For some researchers who want to know both about structure and function, what we could do is overlay a PET scan on top of a CAT scan. Given the CAT scan is useful for structure and the PET scan is useful for function or activity, we can use them in conjunction with one another or use them together. The MRI, similar to a CAT scan, is going to be looking through soft tissue, but instead of using an X-ray like the CT scan did, the MRI uses a magnetic field. It produces relatively similar images to the CT scan. This also does mean, like the CT scan, an MRI is very useful when we are looking at structure or location. But the MRI alone will not be helpful if what we want to understand is activity or function. Our last measure, however, the fMRI, takes the MRI one step further. The F here stands for functional. Just like the MRI, the fMRI will use a magnetic field to look within the brain. But now, beyond simply exploring soft tissue, the fMRI is detecting blood flow. Looking at blood flow allows us to look at activity that is going on in the brain. This means the fMRI is pretty useful for studying function, but it also gives us structure. So just like using the CT scan and the PET scan together, which would allow us both structure and function, the fMRI by itself allows us to examine both structure and function.